Hey guys, this video is on how to calculate root mean square velocities, otherwise known as the speed of sound. Okay, let's get this. Okay, so this is root mean square velocity, basically how fast particles move. It's given by this equation here, which is written wrong. There's a little squared up here. Okay, so it's a pretty simple equation. Just has this part here is actually not all that important, so we can just scratch this part out. We don't really care about it that much. And then we still have this part here. Okay, so what is this part? What is R? Is it the 0.08 thing again? No, it isn't the 0.08 thing again. This time it's the 8.3145 thing. Okay, so why is it different? Okay, because it has different units. The other value has different units, and you really want kilograms meter squared per second squared over moles Kelvin for this one, because if you look at the other variables, you have temperature, that cancels, you have the mass, that cancels, and then you have the square root, gives you meters per second. So that's convenient. It should also be noted that the joule is this part here. So this can be rewritten joules over moles Kelvin. But using joules and watts and stuff like that kind of messes up the SI units, makes everything more confusing. So you should always just write out the full units. That way if there's a mistake, it's pretty obvious. Okay, temperature is in Kelvin, like always. You have, this is the part that is kind of weird. You have the mass of particles is kilograms per mole. Okay, so why is it kilograms? Well, because kilograms is in the R value, so you have to convert your molar mass to kilograms per mole, otherwise this won't work, and 3 is 3. Okay, and I've written on the background, once again, go me. Oh, and I had to move down. Oh no, I messed everything up. Okay, I think that's pretty good. So now let's get rid of this. Nope, get rid of this. And I wrote a question on this root mean square velocity. Okay, so what is the sun's core temperature if the average helium atom there has a velocity of 291,000 meters per second? So that's pretty fast, but we can definitely still figure this out. It's doable. Alright, so we have this equation here, but we want to solve for temperature, not root mean square velocity anymore. So we're going to rewrite this equation. So the first thing that we're going to be doing is going to take this, square it, and we're going to take this and square it. We're going to get u squared equals 3 RT over the mass. Okay, so now let's rearrange that a little bit. For temperature, we get temperature equals U squared times M, and that's all over top of 3R. Okay, and we know everything else here, so now it's just a matter of throwing it in the equation. So here we know U is the average velocity, so we have 291,000 meters per second, and we're going to square that. And we're going to multiply that by the mass, which is 4 grams per mole. It's helium, but wait, we don't want grams per mole, we want kilograms per mole. And we know if there's 4 grams per mole, there's not going to be as many kilograms. So we'll divide it by 1,000. We get 0.004 kilograms per mole. And we put all of this over top of 3R. Again, 3 is 3. R is 8.3145. Then we have, oh boy, kilograms times meters squared all over seconds squared mole Kelvin. Okay, so now as you can see, pretty much everything here cancels. So we have the moles will cancel, our meters per second will cancel, and our kilograms will cancel, moles will cancel. The only thing we're going to have left is Kelvin, which is what we want. Okay, so let's draw an equal sign. Can't forget the equal sign. Just throw that into your calculator, and you will get the temperature of the core of the sun, which comes out to a whopping 13 million degrees Kelvin. Okay, so yeah, that's pretty hot. And is it reasonable? Yeah, it's reasonable. And I think that's pretty much everything you have to know about the root mean square velocities, but it's just like any other equation you've ever seen. There's different variables that you could have to find for, in which case you just rearrange for it. And similarly, they could say, like, how much does the temperature change if the velocity changed by 100 meters per second? And then you would just have to go in, do it before and after, and subtract and such. So it's nothing really too bad. Okay, so I guess I'm done.